I want to show you how to find the intersection point of two lines in 3 space. So in 2 space, when you're just dealing with the plane and you've got 2 lines, you know for certain they're going to intersect if they're not parallel. So 2 lines, if they're not parallel, at some point they're going to intersect. That's not the way it is when you throw in the 3rd dimension. So you've got 2 lines out here, and let's suppose they're not parallel. They might intersect or they might not. And I want to show you how to determine if they do intersect, and if they do, what that intersection point is. So here I've got 2 points. I've got L1 and L2, and I want to know if there's a value for T and a value for S that will make the X, the Y, and the Z the same for both lines. So here's how I can proceed. I can take this T, I can take this L1, and I can say, okay, X is equal to T plus 4. And then I go to L2 and I say, okay, the X is equal to 3S minus 7. Now those need to be the same. There needs to be a value for T and a value for S that will give me the same X value in this point of intersection. Now I want to do the same thing for the Y's. I want to say, okay, negative 2T plus 5, it needs to equal the Y in the other line, which is S minus 8. So Y equals S minus 8. So those two have to be equal. The T's and the S's, we need a T and an S so that the X's for both lines are the same and the Y's for both lines are the same. And then after I find that T, I find that S, I'll plug it into the Z to see if the Z's are equal for those values. But it's enough just to work with these first 2 here. So I'm going to solve these. I've got T minus 3S equals negative 11. And that's me just bringing the S over with the T and moving the 4 to the other side. I'll do the same thing for the second equation. I've got negative 2T minus S equals negative 13. And now I just solve this. This is just a system of equations to solve. And probably a good way to solve this would just be by elimination. Multiply the top equation by 2, and I got 2T minus 6S equals negative 22. And then I've got 2T down here minus S equals negative 13. Yeah. Okay, so I just add these now using just elimination, and I get negative 7S equals negative 35. Divide by negative 7, and I find S is equal to 5. Yeah, so there we have it. So there is S is equal to 5. Now, as far as T, I can go back any place I have S and T together and find out the T. So I have T minus 3S equals negative 11. And, I got that from right here. And what I want to do is put in the 5 for S and solve this. So I've got T minus 15 equals negative 11. Add 15 to both sides, and I got T is equal to 4. So it looks like when T is equal to 4 and S is equal to 5, the X's and the Y's for line 1 and 2 are the same. So let's check that out and see. Here goes L1. I'm going to put in, first of all, for the X, I have T plus 4, so that's going to be 4 plus 4. For the Y, I have negative 2 times 4 plus 5. And for the Z, I have 3 times 4 minus 5. Now, all I did was I just plugged in this T equals 4. I plugged it in here, here, and here. And let's see what I get. When I do that, I get 8. And then I've got negative 8 plus 5, that's negative 3. And then I've got 12 minus 5, which is 7. So in line 1, when t equals 4, I get this point. Now, I can check out line 2. And line 2, I know the x and the y is going to be the same. It's going to be 8 and negative 3. What I don't know about is the z. But here I go. Now, this time, s is equal to 5. So we've got 3 times 5 minus 7, comma, 5 minus 8, comma, and 2 times 5 minus 3. Okay, so let's see what that is. That's 15 minus 7. Well, that's 8. 5 minus 8, negative 3. Oh, here it goes. Drum roll. This one has to be 7. If it's 7, then that's this 8, negative 3, 7 is the point of intersection. So let's see here. We got 10 minus 3. That is 7. So yes, those two lines, L1 and L2, do intersect, and they intersect at the point 8, negative 3, and 7.